Hello everyone and welcome to my channel. This is Mr. Meter and we are going to talk about the translation of an HDLC packet, which is a data protocol for communication in DLMS COSEM connections. In a network communication, when data is transferred from device A to device B, several layers and protocols are used, depending on the communication infrastructure and method. Let us briefly explain these layers and protocols before we talk about HDLC packets and communication. OSI stands for Open Systems Interconnection and is a model that describes 7 layers that computer systems use to communicate over a network. As you can see, the layers are in a particular order that best visualizes how data from the applications we use is prepared and translated to different layers and back again. OSI model is no longer used in the modern internet, but it helps to visualize how the network works. Each of these layers represents a different protocol type, language, and framework as they descend into each other. From the application layer to the physical layer, messages and data are translated and transmitted. High-level data link control, or HDLC, is a bit-oriented, code-transparent, synchronous data link layer protocol. Alright, what is the HDLC packet structure? We are not going to go into detail about the HDLC protocol in this video. I'm going to make a series of videos dedicated to the HDLC protocol and everything related to it. In this video, we will focus on the structure of HDLC packet in the DLMS COSEM protocol and how to translate and understand them. This is the basic structure of an HDLC packet. The flag field is the start and the end indicator of a frame. It uses a delimiter of 7E. The address field identifies the source and the destination addresses, and it is 8 bits long, supporting up to 256 addresses. Depending on the communications network, this field can be more than 1 byte, and each byte can have up to 128 stations. Next is the control field, which determines how the communication is controlled. There are several types of frames in HDLC protocol: I-frame, S-frame, and U-frames, information, supervisory, and unnumbered frame types. This field contains the transmit and receive sequence numbers, function bits, and the PF bit, which stands for pole final bit, and is a single bit with 2 names. It is called pole when the bit is a part of a command set by the primary station to obtain a response from a secondary station, and final when the bit is a part of a response set by the secondary station to indicate a response for the end of transmission. In all other cases, the bit is clear. The information field is the data transmitted between 2 stations, and it is transparent. The length varies depending on the data being transmitted and also on the network type, window size, and many other causes. Note that not all HDLC frames contain an information field. The frame check sequence, or FCS, is used to detect errors using CRC16 or CRC32 algorithms. Remember that the CRC calculation is done at the receiver end, and if the results don't match, an error is raised. This field can be either 2 or 4 bytes. This function is used in HDLC packets to check for frames and the data corruption. Finally, the last field is the flag field. In HDLC communications, flag fields are required at both the beginning and the end of the packet. The final packet will look as shown below, and this is what will be transmitted between network sites. On each HDLC packet, the data for the DLMS COSEM communication is transmitted. The data in includes length, target address, source address, frame type, PDU, request type, invoke ID and priority, attribute descriptor or result, class ID or data type, and attribute ID. The data can be translated into an XML-like form, and you can see the example on the right corresponding to each segment in the packet. To translate an HDLC DLMS COSEM packet, you either need to know the corresponding data type and each segment type, or you can use third-party tools such as Gurux DLMS Translator, which can be downloaded from their website at the address in the description of this video. Third-party tools eliminate some of the parts of the packet we discussed in the previous slide and only provide the user with the data that is being transmitted between nodes, allowing for much faster debugging. But if you want to know more about the network communication side of the transmissions, then you need to translate those parts as we discussed earlier. The packet you see on the right is translated using the Gurux Translator, and the packet itself is shown above. The DLMS Green Book mentions and describes all the necessary references you need to translate the packet, so I recommend you get the book and go through it all if you are either trying to write a program to communicate with a DLMS meter or device, or if you are writing firmware code for a meter or device. Let's delve into this sample packet and see how we can translate the data. The first part of the packet is the flag, which we know it as the famous 7E, and always marks the start of the data packet. The next part is A01C, which marks the frame type and length and comes always after the flag segment. The next, as you see, indicates the target and source addresses for data transmission, which is crucial for HDLC communications. Next will be the iframe, which is in this case 03. After this, there is the HDLC frame type, which is 32 in this packet. And after it comes the HDLC HCS segment, which is the header check sequence field. This next segment contains the DLMS COSEM LLC addresses. Next one is C001, which based on DLMS standard means GET request normal. This segment means that the request type is GET and it is a normal GET. There are several types of GET requests. For example, normal means that for requesting data on every attribute or logical name, you need a separate request. The C1 that comes after is the invoke ID and priority segment, which means that the priority is high, service class is confirmed, and the invoke ID is 1. Coming after this is 0017, which is the class ID referring to DLMS class ID. There are many classes in DLMS COSEM standard. In this example, this refers to IEC HDLC setup. After class ID comes the instance ID with the value you see in the packet, which is basically the logical name that translates into OBIS code for IEC HDLC setup object, which is 0122000255. For addressing the specific attribute of an object in DLMS, we use the next segment, which is 0200, and that is attribute ID and the end padding. The 68B2 is the HDLC FCS field, which since it is in a request packet, then it will be in poll state. And finally, the end flag 7E. Remember this, every HDLC flag can have different fields, especially in information field, depending on the transmitting information, and this was only an example. Now we will connect to a DLMS meter via Gurux DLMS Director application, and then we will read and IEC HDLC setup object, and then we will use the packet and we will translate the packet inside the translator application, and we'll show you how it works. Okay, let's connect to the meter now. I can right click on any object of the DLMS objects within the meter, and then I'll click on connect. You can see the transmission packets here. Then I will right click on the object I want, and then I click read. I'll copy the transmitted packet here, and I'll click disconnect. And then in the tools menu, I'll go to DLMS Translator. You can see a window opens. I will replace this text here with the packet I just copied, and I will choose the interface to HDLC. It can vary in different connection types, and I just click translate here. After translation, you can see the data packets translated into XML form in the right side, and you can see, for example, it's a GET request with all the attributes we explained earlier, and with the GET response, which is for example, data type is enum and the value is 05. As I told you earlier, you can go through all these data types and segment types and frame types in DLMS Greenbook, and there are tons of knowledge there you can find. And this was a basic explanation of how to translate the data packet using Gurux DLMS Translator. You can repeat this procedure for any different objects and classes also, and learn more about all the data packets and their differences. This was the basics of translating an HDLC packet in DLMS COSEM communications, which you can use to debug packets you send and receive when interacting with DLMS devices. Please hit the subscribe button, and we will be talking much more on network protocols, transmitting data modes, and all about applications of data measurements and transmission in energy grids and metering industry. Thank you.